What's up everybody, this is Teacher Ivan from NextGen Academy. Our goal in this channel is to help you achieve your highest potential and to help you understand subjects in the easiest and the most efficient way. If you'd like to get more tips and tricks on how to achieve A star in your IGCSE, don't forget to like, comment, share and subscribe to this channel. Lastly, if you need any help in your studies, you can always head on to our website, link in the below, or our Instagram, drop us a DM and we'll be able to help you. Enjoy this video and I wish you all the best.
Okay, welcome back, my NextGen family. Okay, today we'll be going through this paper, which is the May June 2025 paper, paper 1-1. Okay, what are things that we need to take note as we practice? You have to don't use calculator. Okay, there's no rounding up of values to three significant figure. Maybe for angles, one decimal place, but you see they never specify over here because we won't get irrational numbers, okay, or the numbers that will keep on recurring. Other than that, same thing, 80 marks. The only thing that I think you all need to take note of is you need to be careful on your timing, okay? Timing, very, very important here. Okay, what do we need to know for the formulas? Most of the formulas here are exactly the same, except these few formulas. Okay, you see these few formulas here. Last time, there is no circles, okay? There is no circles. So how, okay, how do we apply this? This is a new chapter, and so far what I observed, actually the circles question all not very hard. Okay, it's still pretty easy, okay? So we hope that your exam, okay, your upcoming exam will be as easy as this also. Then they give you extra few formulas on shapes, which is your area and volume. This is normally used for differentiation. Okay, normally like your rate of change. Okay, we go straight to question number 1. The other formulas are all the same. Okay, question number 1 is a vector question. Given that PQ equals to negative 37, PR, for PR is negative 28. Find RQ. Okay, we will join both of these together. RQ equals to RP plus PQ. This is called the head to tail method. Okay, everyone knows from maths also, where you just need to join the head to tail of the other one. Then our final vector will be R and Q. Okay, we have PQ, but we don't have RP. Can we rearrange this to become RP? Okay, so we can rewrite this. 4 PR is negative 28. We divide the whole thing by 4, so this will be 1 over 4, negative 28. Then we want to switch the position of the vector RP, we multiply it by negative. Okay, so negative 1 over 4, bracket negative 28. Okay, if you want to open up the bracket here, also can. Okay, but I'll just write it over here. So we'll get negative 1, 4, negative 2, 8. If you want straight right into here, also it's fine. Plus PQ, minus 3, 7. Okay, let's open up the bracket. Negative 1 over 4 times negative 2, we'll get 1 over 2 plus negative 3, so minus 3. Negative 1 over 4 times 8, we'll get minus 2 plus 7. Okay, using your mental calculation. What is 1 over 2 minus 3? Minus 3 is minus 6 over 2. So this will be minus 5 over 2. Minus 2 plus 7. This will be equals to 5. Okay, so it will be negative 5 over 2, 5. Okay, question B. The vectors A, B, C. A is alpha I plus 6j. B equals to 4i plus beta j. C is 2 alpha plus 5 beta I plus 20j. Alpha and beta are scalars. Given that C equals to 3a minus 2b, find the value of alpha and beta. Okay, this is actually just a simultaneous equation. Okay, where we need to substitute all the values, then we compare the I and the j. Okay, we fit in the values. C equals to 3a minus 2b. So 2 alpha plus 5 beta I plus 20j equals to 3 alpha I plus 6j minus 2 4i plus beta j. Okay, plus beta j. Okay, we want to open up the right hand side and then gather all the I and the j's into one bracket. 3 alpha I plus 18j minus 8i minus 2 beta j. Okay, we got this I and I, we factorize it, put into one bracket. 3 alpha minus 8, bracket this, I plus 18 minus 2 beta j. Okay, I and j's are not unknowns. I and j's is the direction. Okay, next time when you all go to college, I and J, you'll see a lot of these I and J's. Okay, I is normally like your X direction, J is your Y direction. Okay, now what do we do is we will take these I values, compare with this I value. That means you equate both of it with each other. Then we'll take these J values, equate with these J values. Okay, so I want you all to write down, okay, your I value. 2 alpha plus 5 beta equals to 3 alpha minus 8. Okay, anything that we can do? Okay, because when we got two unknowns, cannot solve it yet. We open the other one first. Okay, let's do the J first. Because if you see the J, there's only one unknown. 20 equals to 18 minus 2 beta. Okay, this is good. So 2 beta equals to minus 2 beta, negative 2 divided by 2, negative 1. Okay, we've got this ready. Let's substitute the beta equals to negative 1 into here. Okay, so we're going to substitute sub beta 1 equals to minus 1. So 2, okay, let's maybe simplify this first. 2 alpha minus 3 alpha equals to minus 5 beta minus 8. Okay, sorry, let me just make this a bit nicer first. Okay, this will be minus 3 alpha equals to negative 5 beta minus 8. Okay, we can sub here. Okay, sub over here. So minus 3 alpha equals to negative 5, negative 1, negative 8, 5 minus 8 is minus 3. Hey, hold on a minute. Okay, what happened to my math today? Minus 5 beta. Beta. Hey. Okay, sorry. Okay, teacher maths today. Yeah, I need my coffee already, even though at night. Okay, negative alpha. This one 5 minus 1. Therefore, alpha is equals to minus 3 divided by minus 1. We will get 3. Okay, so beta is equals to negative 1. Alpha is equals to 3. Alright, okay, if you can do number 1, can you type 1? Can you use decimal? Decimal for which one? Previous question. Minus 5 over 2, is it? Okay, yes, can. They never say cannot. Okay, in fact, the mark scheme write minus 2 over 2.5. Okay, both ways you want to present also can. So if you write minus 2.5, also same thing. Okay, type 1. Okay, I see all the ones. Good. Okay, no question, huh? All right, awesome. Let's go to question number 2. Okay, number 2, solve the inequality 3 minus x, 5x plus 8 more than or equals 9 minus 3x. Okay, this most likely will be a quadratic inequality. Okay, we open out the bracket first. 15x plus 24 minus 5x squared minus 8x more than or equals 9 minus 3x. Okay, we rearrange it, everything to one side. We put it all to the left-hand side. And then we rearrange to ax squared plus bx plus c. Okay, so here will be minus 5x squared, 15x minus 8x plus 7x plus 24. Okay, we simplify the left-hand side first. Now bring everything to the left-hand side. Minus 5x squared plus 10x plus 15 more than or equals to 0. Okay, can we simplify this? This one we can divide the whole equation by negative 5. Okay, remember when we do inequalities, if we multiply or divide by a negative, we will need to change the direction of the symbol. Okay, so change from more than to less than. This will be x squared minus 2x minus 3 now becomes less than or equals to 0. Okay, next step, we're going to factorize this. X plus 1, x minus 3 less than or equals to 0. X is equals to negative 1, x is equals to positive 3. Okay, the next thing is we're going to draw out, okay, just do a rough sketch. This one no marks, but you can draw it out to make it easier for you to see. Okay, put the smaller one on the left-hand side, the bigger root on the right-hand side, and then less than means in between. So the answer will be x is in between negative 1 and 3. Okay, less than, equal, less than, equal. All right, if you can do this, can you just type number 2? Okay, so far easy. Question number 2. Okay, let's go to the next one. Okay, when to change the sign again? When you multiply or divide by a negative value. Negative value. So you see I divided by -5, right? So that's why I need to change the symbol. So as long you multiply or divide by negative. Is it necessary to draw the graph? No. No need. I draw so that all of you are clear what am I doing. Okay, any other question? All good? All right. Okay, let's move on to question number 3. Okay, just now someone mentioned number 3. Okay, number 3, this is a circle question. Okay, so circle, so far I think it is quite straightforward, but remember you all need to also recap back on your circle theorem. Okay, so if you don't know your circle theorem, go recap back from your mathematics. Okay, point A has coordinates 3, -1. A circle has equation x minus 4 bracket square plus y plus 3 bracket square equals to 5. Okay, do you all remember how does circle works? This negative of this value is the x coordinate of the center. Negative of this value is y coordinate of the center of the circle, and this is r squared. Okay, y'all can always refer back to the formula sheet. Okay, where does the formula sheet say? X minus a bracket square plus y minus b bracket square equals to r squared, where a and b are the center of the circle, the coordinates of the center of the circle. Okay, show that a lies on the circumference on the circle. How do we show that it is lying on the circumference? You just need to satisfy the equation. Okay, both the equation, when we sub it in, it means let's say we sub x equals to 3 and y equals to -1, it should be equals to 5. All you need to prove is this. Okay, so sub 3, -1. Okay, we'll do 3 minus 4 bracket square plus -1 plus 3 square. Okay, do some sort of working so that at least can see. Okay, here will be 1 plus 4, which is equals to 5. And you can write here, show. Okay, question B. Given that AB is a diameter of the circle, find the coordinates of B. Okay, for any sort of questions that you all can roughly sketch it out, let's say coordinate geometry, circle, straight line, I want you all to sketch it out. Okay, just try your best to sketch it out so that you can visualize it. Even shapes, just draw it out. Okay, this one can draw it. Given that AB is the diameter of the circle, find the coordinates of B. Roughly sketch. Okay, so we got a circle. Okay, let's say we got a circle. Okay, I draw it here. Okay, we've got center. Okay, what's the center? 4 minus 3. Okay, 4 minus 3. Let's call this center O. Then we have a point A. Okay, in relative to here, A is 3, -1. So -1 it is, okay, where's -1? Higher, right? So just try your best to draw. Then they say it is a diameter. AB is a diameter. So B is probably somewhere around here. Okay, let's call this XB, YB. Okay, so what's the relationship? The center, because since this is a diameter, the center of the circle is also the midpoint of AB. Okay, you write down here also first, the center is 4, -3. So we're going to use midpoint formula. Okay, using the concept of midpoint. XB plus 3 over 2 is equals to 4. YB minus 1 over 2 is equals to -3. Okay, let's solve for this. XB plus 3 is equals to 8. X coordinate 8 minus 3, which is equals to 5. Okay, YB minus 1, we multiply this by 2. This will be -6. -6 plus 1 will be -5. Okay, coordinates of B, you can write B is 5, -5. Okay, normally when they want us to write coordinates or points, you just put into point form. That means your bracket, X, comma, Y bracket. Okay, the last one. Okay, I think just now some of you all were asking this. Is it the last one that you all had issues with this. Okay, find the equation of the tangent to the circle at A. How to draw the equation of tangent? Okay, this equation of tangent, right? So what is the relationship between the tangent with the circle and maybe also this line? Okay, because we already found the diameter. What's the relationship? Okay, this is according to one of the circle theorem, the tangent to the radius, okay, or radius or diameter, this will form a 90 degrees angle, right? Okay, so what do we need to do? There are two things, right? Okay, we need the point. Okay, we already got the point. Now we need to find what is the gradient of this tangent. The gradient of the tangent, how can we find? We find the gradient of this line first. So you can find AO or OB, AB. I will use AO because my A and O is confirmed, okay, or more or less should be correct already, unless you make a small mistake. Okay, rather I use OB, AB. Find the gradient of AO, then find the perpendicular gradient. Okay, so gradient of AO. Okay, this is your radius, okay, using the radius. We do y2 minus y1, so minus 3 minus 1 over 4 minus 3. Okay, this is minus 3 plus 1 minus 2, oops, over 1, which is minus 2. Okay, then the gradient of the tangent, we'll use the negative reciprocal. So negative will become positive. Now it's positive 1 over 2. Negative reciprocal. Okay, what formula do we use in math when we do straight line? To be safe, I want you all to use y minus y1 equals to mx minus x1. Okay, try not to start with y equals mx plus c because most of the mark scheme, okay, the official mark scheme, they will give you marks from the y minus y1 equals to mx minus x1. Got it? Okay, so we're going to use which point? We're going to use point A. Okay, A is 3 negative 1 and the perpendicular gradient, which is 1 over 2. Okay, we're going to sub into y minus y1 equals to mx minus x1. Y minus minus 1, so this is y plus 1 equals to 1 over 2 x minus x1. Okay, do you need to simplify it to y equals mx plus c? Okay, do we need to simplify it to y equals mx plus c? Okay, actually, for NMath, don't need. Okay, but if you do, also it's fine. Okay, if you do it, it's totally fine also. So, what I want to highlight to you here is that try not to start with y equals mx plus c because I'm scared sometimes maybe the marker is a bit particular and then they just follow the mark scheme. Then they're like, different the answer. Because if you later I'll show you all the official mark scheme, they give you full marks over here already. Okay, so we want to try as much as we can just follow the rules. But if you want to open up, these are no issues. Okay, so y, you all go and open this up. Y equals to half x minus 502. But this is not necessary. Okay, number 3. If you can do this, can you type 3? Okay, you can write here. This can be final. Okay, just type 3. 3, 3, 3, 3. Okay, awesome. So circles. Circles so far, I see all the questions all quite simple. Okay, I really hope that is easy for you all also. Okay, let's move on to question number 4. Okay, getting harder already. X to the power of 1 over 3 minus x to the power of 1 over 6 equals to 2. How do we solve this? Okay, first of all, we need to define what type of equation is this. Okay, anyone? What type of equation is this? What chapter is this under? Okay, this is a log. Okay, is it a log chapter? Why need log? Why do we need log over here? Okay, no, it's not a log question. Okay, this is actually a, yes, okay, Jing En, very good. Okay, not just indices, okay, but a complex quadratic equation. Okay, can you all see or not? Yes, we do the let one. This is categorized as a complex quadratic. Okay, how do I know or how do we know that it's a complex quadratic equation? Okay, what is the nature of a quadratic equation? X squared x power 1, then no x, right? So we need to see the power like this. The power will always be in this form. The first one will be power 2. That means it will be 2 times of the middle one. Then the last one, no power. So I want you all to remember this format, 2, 1, 0. So you look at the power first. Is 1 over 3 2 times of 1 over 6? Yes, right. Okay, we 2 times 1 over 6 is actually 1 over 3. Normally we are not familiar with the root one, right? But it is 2 times. Can you all see? This is 2, this is 1, then this one, no power. Okay? So, you learn how to identify this form first. 2, 1, 0. Then we call it the let method. Okay, I want you all to bring it all to the left-hand side first. So, x to the power of 1 over 3 minus x to the power of 1 over 6 minus 2 equals to 0. Okay, we can write it like that. X, if you are not clear, you can write it as x 1 over 6 square minus x to the power of 1 over 6 minus 2 is equals to 0. Because you see, 2 over 6 is actually 1 over 3. Okay, this step is not necessary. Just my explanation for you. So when we can see power 2, okay, power 1, no power, we are going to let the middle value equals to another alphabet. Okay, so we can say let y equals to x to the power of 1 over 3. Sorry, 1 over 6, not 1 over 3. Why did I say 1 over 3? Okay, 1 over 6. We can rewrite it to y squared minus y minus 2 is equals to 0. Go and solve for this first. So we get y plus 1, y minus 2 equals to 0. Y is negative 1. Y is equals to 2. Then we are going to change it back to x to the power of 1 over 6 equals to negative 1, and x to the power of 1 over 6 equals to 2. Okay, clear? All right. Now, from here, what is the next step? Let's look at the first value of x to the power of 1 over 6 equals to negative 1. How to do this? X to the power of 1 over 6 equals to negative 1. Okay, question. Got answer or not? This is what? Power 1 over 6 is 64. The negative 1 first. X to the power 1 over 6 equals to negative 1. Equals to 1. Okay, everyone agree? Should we get two answers? 1 and then this one 2 to the power of 6. Okay, can this be a solution? X to the power 1 over 6 equals to negative 1. Can? No. Why not? Okay, why cannot be a solution? Negative? Okay, why negative cannot? Why when power 1 over 6? But if I use algebra, can't I just make it to power 6? Negative 1 to the power of 6, I'll get 1, right? But how come cannot accept? Okay, so I need you all to remember this. Okay, think in terms of square root first. Can square root be, let's say we want to solve for x to the power 1 over 2 equals to negative 1. Can we solve square root x equals to negative 1? Okay, if we never think further, okay, we may say can lah, right? Because square root equals to negative 1, I can bring the square root to here to become square. Okay, but what you need to remember is that for all types of square root, okay, or any type of even root, you cannot get a negative value because you always need to be a positive value. Okay, so you all write this down. For all even roots, even means square root, fourth root, sixth root, eighth root. Okay, cannot be negative. Okay, so even roots, it's square root x, fourth root x, sixth root x, okay, eighth root x. We also can rewrite it as x power 1 over 2, x power 1 over 4, x power 1 over 6, x power 1 over 8. You will get a math error. I mean, basically, there's no solution. Okay, there's no solution for this. So this you have to reject. Even though algebraically you can solve it, because of 6th root, okay, 1 over 6 is 6th root, there's no negative value. You only can get a positive value. Okay, but for this, we can solve it. This will be x is 2 to the power of 6. 8 to the power of 6 is equals to 64. You only can present one answer. Okay, if you don't reject it, then you'll get minus 1 mark. Got it? Okay, the next one. Solve the simultaneous equation. Log x plus 2y equals to 0, x squared plus 4x plus y is equals to 1. Okay, this is a simultaneous, so we simplify. Let's get rid of the log from the first equation. Okay, I'll call this equation 1, this one equation 2. Okay, we start from equation 1 first. Log x plus 2y is equals to 0. Okay, I want to get rid of the log. I will do log form to index form. So x plus 2y is equals to 10 to the power of 0. Okay, LG is log base 10. Then here will become x plus 2y equals to 1. Okay, let's see. Okay, we look at the other equation. There's a x squared, so this one we have to do a substitution. So I will make this into x equals to 1 minus 2y. Let's call this equation 3. Then we will sub equation 3 into equation 2. 1 minus 2y squared plus 4 bracket 1 minus 2y y plus y is equals to 1. Okay, this one, slowly open it up. 1 minus 4y plus 4y squared plus, okay, this one can we straight away open up? 4y minus 8y squared plus y. Okay, the 1 I bring to the left hand side also. Minus 1. Okay, we gather all the like terms. 1 and negative 1, so this one will become 0. Minus 4y, y, and y, so we'll be left with y. Then 4y squared minus 8y squared. So we will end up with minus 4y squared minus plus y. Okay, minus 4y squared plus y equals to 0. Okay, I don't want it in this form. I want it in positive. So times negative 1. This will become 4y squared minus y equals to 0. Okay, factorize. 4y minus 1 equals to 0. Y is equals to 0. Y is equals to 1 over 4. Okay, nice. We already got the answer. Okay, let's sub in back into equation 3. Okay, so we sub y into 3. X equals to 1 minus 2 times 0. X is equals to 1. X equals to 1 minus 2 times 1 over 4. Okay, this is 1 minus 1 over 2. We get x equals to 1 over 2. Okay, so we get 1, 0, and 1 over 2, 1 over 4. Okay, you don't have to put into point form like this, but at least you align it properly. Make it clear, because you see, there's sometimes the answer in the middle is a bit hard for the marker to see. So I write this down, or you can write now at the final here, x equals to 1, y equals to 0, x equals to 1 over 2, y equals to 1 over 4. Okay, so that it's easy for the marker to see. Okay, question number 4. If you can do this, can you type 4? I think the first half of the paper is quite easy. It's the second half. Okay, the second half is a little bit hard. Okay, let's go to question 5. Solve the equation 5 modulus 2x minus 1 modulus plus 8 equals to 23. Okay, we'll bring the negative 8 first. 5 2x minus 1 equals to 23 minus 8, which is 15. Modulus 2x minus 1, 15 divided by 5, which is equals to 3. When we want to take away the modulus, we put a plus minus. Oops. This is 2x minus 1, right? Okay, so 2x minus 1. Okay, this one we just write like that, plus minus 3. So 2x minus 1 equals to 3. 2x minus 1 equals to minus 3. 2x is equals to 4. X is equals to 2. 2x is equals to negative 2. X is equals to negative 1. Okay, this is an easy 3 marks. All right. Can you do square method? If one side modulus, you don't use square. You only use square if both sides is modulus. Okay, but I think you can get the same answer, right? Actually, can. You try and see. Bracket 2x minus 1 square equals to 3 square, is it? Can. Yeah. Sorry. Let me rephrase. Can use. You'll get the same answer. Okay, just stick to the method that y'all prefer. Okay, so the other alternative way is you rearrange until here, then you just square it. Okay, question B. This last time used to be a calculator paper, so you all can just straight away put in the values in the calculator. How to do this right now if you don't have a calculator? Can do or not? Sketch the graph y equals to 5 sine x minus 2 from 0 to 360 degrees. Can we solve this without a calculator? Okay, can lah, because non-calculator paper, right? So you also have to figure it out lah. Okay, so how to do this? I will normally start with drawing out the original graph. Okay, so I teach you all the way that I'll do this question. Okay, at least you need to know how does your sine graph looks like first. Okay, the main points. We've got here 0, 90, 180, 270, 360. Here 1, here -1. Okay, so what I will do is I will write down the values, all these important values first. When my x is equals to 0, 90, 180, 270, and 360, my y value will be 0, 1, 0, -1, 0. Okay, this is my table of values for my normal sine graph. Okay, this one, the most basic thing that you all need to know. Now, how do we convert it into y equals to 5 sine x minus 2? Okay, we know that the sine x value for 0 is 0. Sine x value, that means sine 90 is 1. All we need to do right now, we replace all the sine x value with this value. Okay, this is the calculation that I will do. Y equals to 5 sine x minus 2. Okay, just draw out the same thing again. Okay, so here 0, 90, 180, 270, 360. Okay, by the way, you don't have to present until so nice in exam. All this, I'm just writing so that it'll be beneficial for all of you to see what am I doing. Okay, the working will be like this. To calculate for x equals to 0, because x equals to 0, my y is equals to 0. So 5 times 0 minus 2. When my x is equals to 90, it'll be 5 times 1 minus 2. I'm following this set of values here. Okay, for the sine x value right now. Because y is equals to sine x. Then x equals to 180, 5 times 0 minus 2, x equals to 270, 5 times minus 1 minus 2. And the last one, x is 360, 5 times 0 minus 2. Okay, you calculate all these values first. You get minus 2, 3, minus 2, minus 7, and minus 2. These are the values that we want to sketch on the graph. Got it? Okay, you need to plot the points correctly. It cannot be just a rough estimate. All of it need to be plotted out properly. That means at 0, you need to plot at -2. 90, you plot at 3. Okay, so now I want you to go back to the graph, plot the points. 0, -2. Okay, this is -2. 90, 3. Okay, these are 3. Then -2. Then here is -7. -7. And then -2. Okay, you see, you get a sine graph. Going up, going down. Okay, like this. All right, this is how I will do it. But maybe some of you a bit more advanced now. You say, hey, straight away I can sketch out the graph already. Please go ahead because I don't think they will give you marks for the working. They will just give you the entire 2 marks purely on whether you plot the points correctly or not. Okay, number 5. If you can do this, can you type 5? Okay, 5, 5, 5. Okay, full marks so far. Are we okay? All right. Okay, let's move on to question number 6. A curve has equation y equals to x squared minus 1 over x squared plus 1 bracket to the power of 4. Show that dy dx can be written into this form where a is a positive integer to be found. This is a 5-mark question. Okay, this one. How to differentiate this? There is a fraction inside. Then the entire thing bracket. We need to use both chain rule, okay, for the outside. And then for the inside, what do we use? a quotient rule. Okay, inside the bracket, use quotient rule. So this for the outside part. Okay, outside. This is for inside the bracket. Got it? Okay, let's break it down the inside one first, the quotient rule one first. Okay, let's do the quotient part first, which is u equals to x squared minus 1, v is x squared plus 1. U prime equals to 2x, v prime is also equals to 2x. Okay, then we cross this. Okay, we can just write here. Okay, it's not exactly y prime, but the derivative of this will be vu square minus, vu prime minus uv prime over v square. Okay, this is x square minus 1, 2x minus x square plus 1, 2x over v square. X square plus 1 squared. Okay, we don't do further first. We put into the equation because they want us to simplify to a certain form, right? Okay, so this is what, when we differentiate inside the bracket, we should get this. Okay, now we had to do the outside part also. So dy over dx will be 4. Okay, we differentiate. Okay, we don't differentiate first. We put this one, then we put the differentiate at the back. X squared plus 1 to the power of 3. Then we put the derivative that we calculated, the quotient rule one, which is x squared minus 1. Okay, let's see if we can simplify this. Okay, any way to simplify? X squared minus 1. Okay, wait, hold on. Let me just double check the value. Okay, you see, I gotta be careful because I also wrote wrongly already. It should be x squared plus 1 because vu prime. X squared plus 1, then uv prime. This is x squared minus 1. Okay, you see, I have to also double check it. Can you straight away with the differentiate with the power 4? Can. Okay, remember, I'm just writing so that you all can see clearly, okay, the steps. Okay, let's see. Okay, what we can do here, maybe I factorize this. Okay, factorize this out. So we'll be left with x squared plus 1 minus x squared minus 1 over x squared plus 1 squared. Okay, this part here, see here will be x squared minus x squared, so no more. 1 plus 1 inside here will be 2. Okay, so inside here will become 2, so 2x times 2 will be equals to 4. Okay, then how can we simplify this part here? So we can open up the cube to like this, because you see the final form how they want it. At the bottom, they want power 5. So on the top here, we'll get 4x. Okay, maybe we can write this 4x over x squared plus 1 squared. Right? Okay, why I put a dot here instead of a times? I don't want to get confused with the x. Okay, dot also means multiply. Okay, do we have the form ready? At the bottom, we'll get x squared plus 1 to the power of 5. On the top, okay, there's an x squared minus 1 cube. We'll just take the 4 times 4x, so it become 16x. X squared minus 1 cube over x squared plus 1 to the power of 5. Okay, a is a positive value, so 16x. So as long as you simplify to this manner, you can write. Okay, my advice why I show the u and the v. Okay, just in case if you straight away differentiate it. Okay, some of you all straight away jump to this step here, right? Okay, I think just now what Sky was asking. So if you put straight away dy over dx, just in case if your this step is wrong, right? According to the mark scheme, if I write it like this, u prime, v and v prime, here got 2 marks already. Okay, so this is to avoid from like, let's say if your bottom part is wrong, right? At least you can check, you can get some marks here. For me also, I feel it's clearer that I present it first before we continue doing, because it's quite a complicated equation here. Okay, clearer, right? Okay, if I can write u prime, v prime. You did the u and v or power 4. That means you use quotient rule with x squared minus 1 power 4 and x squared plus 1 power 4. Okay, also can. Okay, do you get the same answer? Okay, as long same answer can. Okay, so the alternative method, okay, what Sky is asking me is that, can you do, open out the bracket here, then this one also power 4, then you'll just do a quotient rule. Okay, you do quotient rule means your u is x squared minus 1 to the power 4, your v is x squared plus 1 to the power 4. Okay, also can. All right, number 6. If you can do this, can you type 6? Okay, 666. Wait, we haven't finished yet. Sorry, let's continue. Okay, this one is the question B, right? Is the funny one. Anyone manage to do this question B? Okay, don't know how to do, right? Especially question B number 2. Okay, we do question B number 1 first. Show that the curve has stationary points where x equals to -1, x equals to 0, and x equals to 1. Okay, let's think back again. What is the dy over dx? Okay, this one is dy over dx, right? Dy over dx. Okay, when we want to solve for stationary point means dy over dx equals to 0. We only take the top part. Okay, you just take your numerator equals to 0 and then solve this. So 16x, x squared minus 1 cubed equals to 0. Okay, we'll get x is equals to 0. Then this x squared minus 1 equals to 0. X is equals to 1. X squared equals to 1. X is equals to plus minus square root 1, which is x equals to 1 and x equals to -1. Okay, so you get these 3 values. Okay, but what I find very funny is this second question. Okay, I don't know why is it only 2 marks. Honestly, I don't know why. Because of the way that they want us to present the answer. Okay, this is actually going back to, okay, we seldom use this method, but right now since it's us over here, right? This is actually what we learned in mathematics. Okay, they say use the first derivative test to determine which 2 stationary points have the same nature and state whether they are maximum or minimum points. Okay, normally for nature, what do we use to prove? We normally use second derivative test, right? Which is d squared y over dx squared. But how do we do first derivative test? Okay, for the first derivative test, we have to use the value of the gradient. You remember? Okay, I didn't teach this in math because in the recent years, we probably never even use this method. Okay, so right now, how come they suddenly put here? Maybe because they want to change the format a little bit. Okay, so let's learn how to do this. So using first derivative test means you're going to use the gradient. Okay, I write down here again. Dy over dx is 16x, x squared minus 1 cubed over x squared plus 1 to the power of 5. Okay, the turning points that we have will be x equals to 0, 1, and -1. Okay, what we are using here is we need to check the gradient for the points before this and after the turning point. Okay, so we are using gradient. Okay, use gradient. This is the first derivative test. Okay, we also look at this entire value here. Do we need to sub in every single one? Because otherwise it's going to take a long time to sub in, and it's only a 2-mark question. Okay, I want you to look at the nature. If you sub in any value into the bottom here, your 0, 1, or -1, 0 squared plus 1 to the power of 5, 1 squared plus 1 to the power of 5, and -1 squared plus 1 to the power of 5, this part here will always be a positive value. We only need to check whether the gradient is positive or negative. In fact, we don't need to know the value. Okay? You just need to use gradient, check positive or negative. Okay? Don't need to solve for the value of it. Okay, this is how we do it. For example, if x equals to 0, okay, this is some sort of quadratic graph. Okay, so that means there is 3 turning points. So we will draw a table like this. X, okay, if we want to test what is the value for, okay, what is the maximum or minimum point for this x equals to 0, you're going to use a point slightly below 0. Let's say -0.5. Okay, cannot be -1 because -1 is the next turning point, right? So you're going to use -0.5 and 0.5. Okay, what is the dy over dx value for this? We just need to check whether it's positive or negative. So this x, if x equals to -0.5, okay, what is the dy over dx value? 16 times 0.5, this is -8. We only take this one, we only take the top value. Okay, the 16x, x squared minus 1. Okay, -0.5 square will be 0.25. Okay, 0.25 minus 1 cube. Okay, remember again, I'm only checking for whether it's positive or negative. Negative 8, 0.25 minus 1, this is negative 0.75 cube. Okay, so this will give me a negative, this one also a negative. Negative and negative will become positive. So that means the value of the gradient for this is a positive gradient. Okay, the gradient for the turning point confirm is 0 one. Okay, so this one you all don't need to calculate. We repeat the same thing for 0.5. Okay, I don't know if there's a simpler way to check, but this is what I think is the working, because yeah, I need to go and see lah, okay, if there's any other way, but according to the mark scheme, you have to present this out, okay, to check whether it's positive or negative. Okay, so here 16 times 0.5 we'll get 8. 0.5 squared, this will be 0.25 minus 1 to the power of 3. Okay, here will become 8 times negative 0.75 to the power of 3. Okay, positive and negative, this will be a negative value. So here is negative. All right. How do we sketch out the graph and check whether it's a maximum or minimum? So this positive, this one gradient is 0, then negative. Can you see? That means it's going like that. The point beside the 0 is at a positive gradient. The point after the 0 is negative. So this one is a maximum. Okay, this point is a maximum point. You go and check for all of it. Okay, I'm just going to write down the working. X equals to 1. Okay, some of it is repetitive already, so you try to calculate for all of it. Okay, now I'm going to do for 1. Okay, the turning point of 1. Then here, 1.5. Okay, we already have x equals to 0.5. X equals 0.5 is a negative. Okay, so don't need to calculate for this. This one will be 0. Okay, let's calculate for x, 1.5. The dy over dx value, 16 times 1.5 is positive 24. And this one 1.25 minus 1 cube, which is 24 times 0.25 cube. Okay, positive and positive, this will become a positive value. So this one is positive. Like this, like this, like this. Okay, so this will give us a minimum. Okay, the nature is a minimum. All right, we're going to repeat one more time for x equals to negative 1. Okay, do the same thing. Okay, for negative 1, I will use the value of negative 1.5 and negative 0.5. Okay, negative 0.5, you go back to the first one, we already found it. It's a positive value. So I just need to double check this negative 1.5. Okay, let's double check this. X equals to negative 1.5. dy over dx is minus 24, 1.25 minus 1 cube equals to minus 24, 0.25 cube. Okay, a negative times a positive will give us a negative value. Therefore, this will be a minimum. Okay, so x equals to 1 and x equals to negative 1. This one, we will call them minimum points. The nature is a minimum. Okay, so this is called your first derivative test. You have to check for the value of the gradient, whether it is a positive or a negative. Okay, if you use second derivative test, yeah, I think the first step here is 0. But if you define what I see, according to the mark scheme, if you use second derivative test, maybe an exam you cannot figure out, right? You do second derivative, but you write this answer, I think you'll get 1 mark. Okay, so you still at least can get 1 mark. So is it, if exam, this type of question come out in exam and you don't know how to do, worth to do or not? 2 marks only. Okay lah, skip it lah. Don't waste your time to do this. Go and do the other questions first. Got it? Okay, an exam you have to plan properly also. Alright, any question? This is question 6. Okay, if y'all got any other ways that y'all have done it, y'all can just snap a picture. Let me see so that I can help you review it. Okay, we are halfway through. We'll take a short break. Okay, we won't take a 5 minute break. Let's take a 3 minutes break. Okay, you can go for a toilet break, water break. We'll come back in 3 minutes time, and then we'll continue the second half of the paper. All right, let's look at question number 7. Find the x coordinates of the points where the curve y equals to 2x minus 9, x squared plus 5 plus 42 cuts the x-axis. Okay, what does it mean cuts the x-axis? Means y is equals to 0. Okay, we simplify this equation first. Let's write it into the form that we expand the bracket and then simplify first. Okay, y. Open up the bracket, we will get 2x cubed plus 10x minus 9x squared minus 45 plus 42. Okay, we rearrange it from biggest power, so it will be 2x cubed minus 9x squared plus 10x minus 45 plus 42 minus 3. Okay, so this is the y value. Okay, we want to solve for cuts the x-axis. Okay, if you see here, this is a cubic polynomial. Which chapter is this actually? Okay, what do we want to solve? We want to solve for this equals to 0. This is actually a factors and polynomial type of question. Okay, we need to factorize this to solve it. Okay, how to factorize? Number 1, we need to find what's the factor first. Wait, but look at this question. How come so different? Last time, we can easily find the factor, right? Now, you have to test to see what is the factor. Do you all remember how to find the possible factors? Using factor theorem. Okay, you need to use the last value. List down all the possible factors based on the last value first. Okay, so what are the factors of, and you just take a positive and negative. Okay, so this step, important, okay? What are the factors of 3? We can take plus minus 1 or plus minus and 3. Then we're going to use factor theorem. Okay, we're going to use factor theorem. Factor theorem, when you sub in the x, the value should be equals to 0. Okay, you have to do a try and error one. Okay, so what I will normally do, I start with 1 first. 1 is the easiest value. You can also do a mental calculation here. 2 times 1, so 2 minus 9 is minus 7. Minus 7 plus 10, 3. 3 minus 3, oh, okay, 9 is already. So our first try already done. But you have to show it. Okay, so you have to write this out. When x equals to 1, y is equals to 2 times 1 cubed minus 9 times 1 square plus 10 times 1 minus 3. Okay, we are using the factor of this. So this will become 2 minus 9 plus 10 minus 3 equals to 0. Okay, so since x equals to 1 satisfy this equation, this is on the concept of factor theorem. Therefore, we can say that x minus 1 is a factor. Everyone understand this step? Okay, can you use other values? Can. Okay, the thing is, you should get 3 possible values. But I will always start with 1 because it's the easiest value to substitute inside. Okay, so before you all go and do your long division, and don't always assume it's 1. I think, okay, for them to give you this question, they will definitely need to give you one of the factors that is a nice value. Okay, so you use this value, you write down all the positive and negative factors of, let's say, 3. Then you write it down. Then you try to do factor theorem. Okay, anyway, if you use another factor also can. Teacher just tell you the other factor you can use is if you sub in x equals to 3, positive 3. So x minus 3 is a factor. Okay. After you do this step, now we're going to do long division. Okay, let's do a long division. Dividing x minus 1. So we're going to take 2x cubed minus 9x squared plus 10x minus 3 divided by x minus 1. Okay, let's divide this. 2x squared, 2x cubed minus 2x squared over. Okay, what I like to do, you put a little negative at the side here. So minus 9 minus minus 2, this will be minus 7. Minus 7x squared plus 10x. And here will be minus 7x minus 7x squared plus 7x. Okay, minus 10 minus 7, we get 3x minus 3. Okay, so we get a plus 3. 3x minus 3. Okay, factor theorem, long division. Okay, so since cuts y-axis, x-axis, we will also write down y will be equal to 0. So we will rewrite this into like that. X minus 1, 2x squared minus 7x plus 3 equals to 0. Okay, this is the y value, then we equate to 0. Then we factorize it. X minus 1, 2x minus 1, x minus 3 equals to 0. Okay, take the bracket equals to 0, all equals to 0. So x will be equals to 1, x is equals to 1 over 2, and x is equals to 3. This will be the three answers. Okay, we call it the roots of the equation. All right, question 7. Please type 7 if you can do this. Okay, any question? Everyone very fast, huh? Okay, let's move on like that. Question 8. Write down the set of values of x for which log 5, 12x minus 4 exists. Okay, this is a log question. What is the domain? Okay, another way to rephrase this is what is the domain? We'll take the argument more than 0. So 12x minus 4 more than 0. 12x is more than 4. X is 4 over 12, which is, okay, we can leave it like this. Okay, or you want to write 1 over 3 also can. Okay, solve the equation. Log 5, 12x minus 4 equals to log x, 6 over log x, 125 plus 1. Okay, normally when you see got two different type of base, we change to same base first. Okay, so I will change to base x first. Okay, we will start from here. Okay, we change it to base x. This will be log x 12x minus 4 over log x 5 equals to 6 over, okay, we look over here, when log x 5, there's something that we can find something similar already. 125 is what? 5 cube. Okay, we write it into 5 cube first. Then why here got this plus 1? Okay, we have to figure out what can we do to make everything similar. Okay, can we change it to something else? Okay, with this 1. Okay, later we figure out. Okay, let's write here 1 first. Okay, look at the nature of this equation here. Okay, anything that we can do or not? Okay, anything that you want to do? Over here, okay, what I think we can do, because got log x5 and log x5 here, right? I will bring like that first. 3 log x5 plus 1. We slowly get rid one at a time. We multiply the whole equation by log x5. Okay, there are multiple ways that you can do this, but this is what I can see immediately right now. Okay, then this 6 and 3 also we simplify it. Cancel, cancel. This will be 2. Okay, so here will become log x 12x minus 4 equals to 2 plus log x 5. Okay, this one we can join together. This we can write it as log xx plus log x5 log x squared plus log x5 log x. Okay, we multiply both of it. X squared times 5. Okay. Did we achieve? Both sides got log x. Okay, if both sides got log x, we can compare both the argument with each other. So this will become 12x minus 4 equals to 5x squared. Okay, let's solve for this. 5x squared, we make it to a quadratic equation. 5x squared minus 12x plus 4 equals to 0. Let's solve this. 5x minus 2. X minus 2 equals to 0. X is 2 over 5. X is 2. Okay, are there other ways to do this? Definitely. Okay, there are probably multiple ways that you can do it. You can even change it both to log 5. Okay, so from the start already, you change it to log 5. So the in-between steps might be a bit different, but your final answer should be the same. 2 over 5 or 2. If you want to write it as decimal, also can. Okay, you want to write it as 0.4, no problem. Okay, this is question number 8. If you can do this, please type 8. Okay, 8, 8, 8. Okay, awesome, awesome. Okay, let's move on to number 9. Okay, just now a lot of you say don't know how to do number 9, right? Okay, can one. Just that very long. This is my worst fear. 1 mark, 1 question, 10 mark question. Okay, this one you mess up 1 step, the whole thing will be wrong already. Integration. The points A with x coordinate 2 lies on the curve y equals to square root 4x plus 1. The diagram shows part of this curve at the tangent to the curve at A. Find the area of the shaded region. Okay, bounded by the curve, the tangent, and the axis. So that means we want to find here. Okay, for this type of question, first of all, we need to plan first. What do we want to do? Okay, to find the area, we can use this triangle minus integral of this part from here to here. Got it? Okay, we plan backwards first. So we need to understand what we need to do. Okay, so the only thing that we have here is y equals to square root 4x plus 1. And they also gave us, they say the x coordinate for A is equals to 2. Okay, so let's list it down first. This is 2. Okay, if here is 2, that means here is also 2. Okay, so we got 1 information. All right, let's maybe find what is this point first. Okay, let's find what is the coordinates of A. Okay, these are no particular order. You, however that you do it. Okay, let's find what is point A first. Point A. Okay, we gotta substitute x equals to 2 into the y equation. So y is equals to square root 4 times 2 plus 1. Okay, this will be square root 9, which is 3. Okay, so I got 1 value here already. 2 and 3. Okay, next, what do we want to do? Okay, we can also, later we can find this value. This one is x equals to 0. Okay, maybe we can say this point is point B. Okay, point B. Then let's call this point C. Okay, point B. What is point B? We are going to substitute y equals to 0. Y equals to 0 into the y equation. So 0 equals to square root 4x plus 1. Okay, this one will be 0 equals to 4x plus 1. X is negative 1 over 4. Okay, or negative 0.25. So this will be negative 1 over 4, 0. Okay, the important point that we need here is negative 1 over 4. So later we need to integrate from here to here. Okay, maybe we can do this first also. Okay, we find what is the integral. What is this point here? Okay, this whole section here, area under the curve. Okay, this one, by the way, in no particular order, however that you all do it. So area under curve, okay, area under curve, we will integrate from negative 1 over 4 to 2 square root 4x plus 1. Okay, this one will be 4x plus 1 to the power of 1 over 2 dx. All right, so let's integrate this. We will get 4x plus 1 to the power of 3 over 2 over 3 over 2 times 4. From negative 1 over 4 to 2. Okay, let's simplify this. 4x plus 1 to the power of 3 over 2. Okay, this one can be written as 2. So 3 times 2 will be 6 over 6. 2 to negative 1 over 4. Okay, I prefer writing all together in one line like that. Okay, can we expand already? I think nothing else to simplify, right? Okay, let's expand this one. So 4 times 2, which is 8 plus 1 over 6 minus, okay, 4 times negative 1 over 4. Okay, this is negative 1 plus 1. Negative 1 plus 1 to the power of 3 over 2 over 6. Okay, this will be, the second value will become 0, so this will become 9 to the power of 3 over 2, 6 minus 0. Okay, what's 9 to the power of 3 over 2? We'll get square root 9 cubed over 6. 3 cubed over 6, which is 27 over 6. Can also be simplified to 9 over 2. Okay, so this section here, okay, this section here is 9 over 2. Okay, maybe I shouldn't list out so many things. Okay, we just need to know the yellow color part. Area is equals to 9 over 2. Okay, what else do we want to find? Now we need to find the triangle. Okay, to find the triangle, we already got a height. Okay, but we don't have this part. We need the equation of the tangent to find the point C. Okay, is there any other way to find? I think we need the equation of tangent, right? Okay, so let's find what is the equation of tangent at A. Okay, equation of tangent. Okay, we find what is the gradient first. dy over dx. Okay, what is dy over dx? 1 over 2, 4x plus 1. Okay, I better write down what's the y first. What am I differentiating? Okay, y is equals to 4x plus 1 to the power of 1 over 2. Okay, the curve. So half bracket 4x plus 1 to the power of negative 1 over 2 times 4. Okay, simplify this. This will be 2, 4x plus 1 to the power of negative 1 over 2. Okay, we are going to substitute because the value where we are choosing from is from the point A. Okay, point A is 2, 3. Okay, point A is 2, 3. So we sub in dy over dx, 2 into this dy over dx. Okay, dy over dx equals to 2, 4 times 2 plus 1 to the power of negative 1 over 2. This will be 9 to the power of negative 1 over 2. Okay, 2 times 1 over square root 9, which is 2 times 1 over 3, 2 over 3. We've got point A, point B, area under the curve. Now we're doing equation of tangent. Okay. Next step. We've got this point A. We've got m is 2 over 3. We're going to substitute into y minus y1 equals to mx minus x1, okay, to find the equation of the tangent. So y minus 3 equals to 2 over 3x minus 2. You can simplify it to y equals mx plus c, 2 over 3x minus 4 over 3. And then y equals to 2 over 3x plus 9. So this one will be plus 5 over 3. Not necessary to simplify, but you can simplify to y equals mx plus c. Okay, what is this equation of tangent for? Equation of tangent is to find B. So point B, okay, point B here is when y equals to 0. Okay, point B, y equals to 0. Maybe I use next page already. Yeah, this is too long. Okay, substitute in here. 0 equals to 2 over 3x plus 5 over 3 minus 5 over 3 equals to 2 over 3x. Then x will be equals to, okay, this one is minus 5 over 2 is equals to x. X is minus 5 over 2. Okay, so the point B will be minus 5 over 2, 0. Okay, I will list it. Now, this is not point B, this is point C already. Why I write point B? Point C. Point C. Yeah, I think we have enough information already. So this is negative 5 over 2. Okay, negative 5 over 2, 0. Okay, to find the area of the triangle, we have this part, the height is equals to 3. The base is 2 minus 5 over 2. Okay, if you want to do in decimals, also can. It's up to you. So this is 2 plus 5 over 2. Okay, 2 plus 5 over 2, which is equals to 9 over 2. Okay, don't want to write so many things. Okay, also try not to write on top. I just show you all so that we can see here. Okay, so the working, okay, for the area of the triangle. Let's go to this next part. Area of triangle. Okay, we'll use half times base times height. So area is half times 3 times 2 minus 5 over 2. Half, this one is 3 over 2 multiplied by 9 over 2. We will get 27 over 4. Okay, now we have the area of triangle, we have area of the curve. Okay, area of curve just now was 9 over 2, so shaded area. Okay, last step here. Shaded area. We will take 27 over 4 minus 9 over 2. Okay, 27 over 4 minus 18 over 4. This will be 9 over 4. Finale. Okay, all of this for 10 marks. Pretty long. Okay, pretty long question. You can see your mental stamina need to be very strong, right? Over here. Okay, we are only at question 9 right now. If you can do question 9, can you type 9? Okay, I'll speed up a little bit. Our last 3 questions. All right. Okay, let's go to question 10. Okay, later if y'all got any question, y'all ask me, but I'll finish up this paper first. Okay, question 10. Show that sine theta over cosecant square theta minus 1 square root plus 1 over 1 plus tangent square theta square root can be written as secant theta. Okay, what's the first step here? Okay, whenever you see a show type of question, most likely you all need to use your identities. Okay, so you go to your page 2, okay, you copy down these 3 formulas first. Okay, whenever you see got show or some sort of square, you copy this down. Okay, so at least you can check it. All right. Cosecant square theta minus 1, this one we rearrange this, will be equals to cot square theta. Okay, let's see whether it is a simplified form. Okay, it is, right? Because from 2 terms become 1 term. Okay, what's 1 plus tangent square theta? We can use this one, secant square theta. Okay, this is a good first step. So secant square theta. Okay, we can remove the square. So now it'll be sine theta over cot theta plus 1 over secant theta. Okay. What's the next thing that we can write here? Okay, we can write sine theta. Maybe you can write as 1 over cot theta is actually tangent theta. Okay, 1 over cot theta is tangent theta. Then 1 over secant theta is cos theta. So we can simplify this to sine. Oops, where's the theta here? Okay, this one is sine theta over cos theta plus cos theta. Okay, which will give us sine square theta over cos theta plus, okay, we want to make it into one term. Let's make this to cos square theta over cos theta. So sine square plus cos square. See, we use all the identities. Sine square plus cos square, this is 1 over cos theta, which is secant theta. Okay, right here, big, shown. Okay, for those who are new here, what I teach you all is to teach you how to cheat. Okay, but you don't go tell your teacher. If you don't know how to do, right, make sure you don't leave this empty. You just write whatever that you know to do, then you just write a shown. Okay, you write, just jump to the final answer. And sometimes you can work both ways also. It's not that you always have to go from the complicated side, because sometimes we get stuck in the middle. So you can get some clues. Okay, what is secant theta? You work backwards. Okay, it's 1 over cos theta. Is there any way that I can write into 1 over cos theta? Okay, don't just fixate, I need to achieve secant theta, because sometimes you write backwards, okay, you may be able to meet somewhere in the middle. Then you just connect the equations. Okay, second one, 3-mark question. Given that secant x equals to alpha, where 3 pi over 2, x is 3 pi over 2 to 2 pi, find sine x in terms of alpha. Okay, for this type of question, normally when they give you a value, then they ask you to find another trigo. That means they give you one trigo, they ask you to find another trigo. You can try to use an identity. Okay, you see which identity you can join with secant and sine. Okay, look at this three identity here. Okay, which one we can see secant and sine? Okay, so what I will do, this one I got sine. Okay, this one got sine. Which one others is sine? Okay, cosecant is also sine. Secant, what's secant? Can I say that secant is cos? Right? Because secant, cos we can change into 1 over secant. Okay, so this is how I will write it. I will use this identity. Sine square a plus cos, or they are using x, right? Okay, sine square x plus cos square x is equals to 1. Okay, let's find, they want sine, right? So we find what is this secant alpha. We rewrite it, secant x equals to alpha. We rewrite it into cos first. So cos x will be equals to 1 over alpha. You just inverse the value. Now we put into this equation. So sine square x plus cos square x equals to 1. So sine square x 1 over alpha square equals to 1. Okay, just rearrange. Sine square x equals to 1 minus 1 over alpha square. Okay, this one we can rewrite into like that. Then sine x is equals to plus minus square root 1 minus alpha square. Okay, then we always have to ask, why did they give us this range of values for x? What does this mean? Okay, so this is referring to the fourth quadrant. Can you see? This is from 270 degrees to 360 degrees. So they are asking us right now whether it is a positive or negative value. So according to ASTC, if a sine value is in the fourth quadrant, is it positive or negative? Negative, right? Okay, because only cos is positive. So the final answer will be negative square root 1 minus 1 over alpha square. Okay, the reason being is because sine is equals to negative in quadrant 4. Okay, question 10. If you can do this, can you type 10? Okay, can stay back a bit, all of you. Okay, we finish it up, but if you really need to go, later you'll just watch back the recording. Okay, let's go to question 11. Okay, because question 12 is the one that I want to highlight. Okay, question 11, I think also quite straightforward. All just put into the formula. An arithmetic progression has common difference d. The third term of this progression is 10. Write down expression for the first term and the second term of this progression. Give your answer in terms of d only. Okay, what is the term value for arithmetic first? A plus n minus 1d. Okay, the formula is in front. So they are giving us here third term. Okay, what's third term? We can say is a plus 2d. They gave us a third term is equals to 10. So 10 equals to a plus 2d. Okay, we rearrange it. A is equals to 10 minus 2d because the expression that they want us later on is only in terms of d. That means we need to get rid of all the a. Okay, so the first term is 10 minus 2d. Okay, what we just found, a. Second term is a plus d. What is d? A plus 10 minus 2d plus d. Okay, which will get 10 minus d. So you just need to present these two answers, 10 minus 2d and 10 minus d. Okay, next one. When each of the first three terms is squared, the sum of this square is 140. There are two possible values for d. Using your answer to part A, find the sum of the first 200 terms of the progression with the smaller value of d. Okay, meaning term 1 square, term 2 square, term 3 square will be equals to 140. Okay, we have term 1, term 2, term 3. Let's write down the expression in terms of d. So 10 minus 2d square plus 10 minus d square plus 10 square equals to 140. We open out the bracket. This will be 100 minus 40d plus 4d square plus 100 minus 20d plus d square plus 100. Okay, bring the minus 140 to the left-hand side. Okay, gather all the like terms with each other. 4d square plus d square will become 5d square minus 60d, 100 plus 100 plus 100. Okay, go and calculate. Minus 140, we'll get plus 160 equals to 0. We divide the whole thing by 5. This will be d square minus 12d plus 32 equals to 0. Okay, then here we will get d minus 4 and d minus 8 equals to 0. Okay, we get d equals to 4 and d equals to 8. We're going to use the smaller value, which is d equals to 4. Okay, since d is equals to 4, a is equals to 10 minus 2d. So 10 minus 2 times 4, which is 2. Okay, so we got a equals to 2. d equals to 4, a equals to 2. Find the sum of the first 200 terms. So as 200, we use the formula n over 2, 2a plus n minus 1d. So 200 over 2, 2a plus n minus 1, so which is 199d. Okay, just in case you're not clear, this one n over 2, 2a plus n minus 1d. Okay, this is a formula given to you in front. Calculate this. 100, this is 4. 199 times 4 will be 796. Okay, 796 plus 4, this is 800. So we get 8, 1, 2, 3, 4. 80,000. Okay, so I think this one is an easy question for 7 marks. Pretty straightforward. Okay, question 11. Please type 11 if you can do this. Okay, don't worry, I'll share this file with you all later on. Okay, so you all can take your time, go process it. Okay, the last one. Okay, anyone managed to do the last question? Anyone tried the last question? Okay, the last question, I think it is a bit tricky. Even when later after I try once already, right? Then I look at the mark scheme. Wow, actually there is 3 different ways that you can show it. Okay, so I'll show you the way that I do it, which I think is the, okay, it might not be the best way, but it's the first way that I think about, okay, to solve it. Then after that, y'all later, I'll share y'all the mark scheme then y'all see which way y'all understand it best also. Okay, number 12. In this question, n is more than or equal to 6. Use an algebraic method to show that nc5 minus n minus 1 c5 can be written as n minus 1 c4. Okay, for your non-calculator paper, this question, very high chance that will come on. Every time when you got the unknown n, you all need to use this formula. This. Okay, for C. Your NCR is n factorial over n minus r factorial r factorial. We normally use this formula when we want to solve for unknown n, okay, or got some sort of unknown n in the NCR. Okay, they are asking us, can we simplify this into this n minus 1 c4? Okay, I'm just going to show you how I would do it. So we put into the formula first n factorial over n minus r factorial for both nc5 and n minus 1 c5. So n factorial over n minus 5 factorial, 5 factorial, minus n minus 1 factorial over n minus 6 factorial, 5 factorial. Okay, how did I get n minus 6? This is from n minus 1 minus 5. Okay, so I just write n minus 6. Okay, now, how do we simplify this? Okay, because we want to make it into one term, so we need to somehow make it, try to join it together. Okay, this is what I will do. N factorial, the top part, okay, let's do the n factorial. So I will simplify each term first, which is n, n minus 1, n minus 2, n minus 3, n minus 4, then n minus 5 factorial. Okay, because I don't want the factorial to be at the bottom. Okay, let's see. Okay, this other, we can do n minus 5 factorial. Then here, we do same thing, n minus 1, n minus 2, n minus 3, n minus 4, n minus 5. Then we stop at n minus 6 factorial. Okay, I want to get rid of the factorial at the bottom. And here, n minus 6 factorial, 5 factorial. Okay, everyone understand what are we doing here? We get rid of the factorial. This and this cancel. This one and this one cancel. Oops, okay, I missed out something. So here is 5 factorial. Okay, this is good already because both got 5 factorials right at the bottom. We can join together to become one fraction. Okay, because the final term we only want one fraction. Okay, look at the top part, your numerator. What else can we do is there are common factors. N minus 1, n minus 2, n minus 3, n minus 4. N minus 1, n minus 2, n minus 3, n minus 4. Okay, the only thing that's different is the n and n minus 5, okay, which we'll leave it inside the bracket. So this is how I will rewrite it. I will write down, I'll factorize out n minus 1, n minus 2, n minus 3, n minus 4. Put the bracket, n minus n minus 5. Okay, this is the blue color part. This is the yellow color part. This one is the blue color part. Okay, then at the bottom will be 5 factorial. Okay, so this step here is we factorize common factors. Okay, then we simplify the blue color bracket, n minus 1, n minus 2, n minus 3, n minus 4. Okay, this one, n minus 5, we'll get 5 here. Okay, then 5 factorial at the bottom. How can we rewrite it? We can write it as like that. 5 times 4 factorial. Okay, why we want to get rid of? Okay, and why I also do this? I just explain to you all the logic behind first. From here, right, I also need to work backwards. Okay, what is n minus 1 C4? Okay, we work backwards. N minus 1 C4. Can we say that is n minus 1 factorial over n minus 1 minus 4 factorial, 4 factorial? Okay, so we need to know what's the final form that we want first, which is something like this. N minus 1 factorial over n minus 5 factorial, 4 factorial. Okay, so you see just now why I don't want this 5 factorial, why I want to get rid of this 5 is because my final form at the bottom, I only want 4 factorial. Okay, so we do one step at a time first. We get rid of this 5 by expanding the 5 factorial to 5 times 4 factorial. Okay, we have achieved this part already. Now what do we not have? Okay, on top, almost there. On top, we have n minus 1, n minus 2, n minus 3, n minus 4. Okay, but we want n minus 1 factorial. At the bottom, we want n minus 5 factorial. Can I say that we multiply both top and bottom by n minus 5 factorial? Cannot. Can, right? Because n minus 5 factorial over n minus 5 factorial is equals to 1. So if I rewrite it into like this, n minus 1, n minus 2, n minus 3, n minus 4, n minus 5 factorial, okay, over 4 factorial, okay, I write this other n minus 5 factorial, 4 factorial. Can I say that the top part, can we simplify this to n minus 5 factorial? Sorry, n minus 1 factorial, because n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, n minus 6, 7, 8, right? So we can rewrite it into this n minus 1 factorial. And at the bottom, you see, we achieve this also, n minus 5 factorial, 4 factorial. So the final step will be this, n minus 1 factorial over n minus 5 factorial, 4 factorial, which is equals to n minus 1 C4. Sure. Okay, I think this question is also a little bit hard. Not so common. Okay, so overall, this paper, I think there's about like maybe 2 or 3 questions. This question and the other one is the first derivative one that is a bit different from the previous syllabus paper. The others are all actually similar. Just that you all know calculator, and like some of it is a bit long. So like the integration one is also, I mean, you all have done it before already. Just that you're doing this without calculator. Alright, okay, question 12. Can do? Can you type 12 if you can do this question? Okay, awesome. This is it for the MJ 2025 paper 11. Okay, I'll brief you all what you all do next. Okay, that's all for this paper.